Good morning, everyone. My name is John Hazlip, and I am with FDOT's Central Office Surveying and Mapping. And this is the first in a three-part webinar series on Bentley's Open Roads Technology Civil Survey for the FDOT SS3 and SS4 Design Survey Workflow. This webinar is intended to be an orientation, a tour, so to speak, of open roads, the DGN, and dialog boxes and configuration settings. In this webinar, I'm going to introduce some of the concepts of open road technology for surveying, the importance of the FDOT resource files and how they interact with the SS4 and SS3 state kit, the characteristics of the SS3, SS4 DGN versus the Legacy DGN that you all know, settings and configurations that are preset for the workspace, and at the end I'll give some tips on avoiding pitfalls inherent in the SS3 and SS4 software. Open roads technology is about 3D design. 3D design uses corridor modeling, and corridor modeling is feature-based. Design survey and surveying and even the right-of-way elements can be featurized, so features are an integral part of the SS3 and SS4 survey workflow. Features are also integral to design in open roads, and therefore their featurized survey data is also. Bentley describes a feature as a real-world entity. Topo data, planimetric data, and also what surveyors know as improvements are the real-world data. Elements become featurized by being assigned a feature definition. There are three types of feature definitions: point features, linear features, and surface features. Point features include spot shots, but it can also be single support signs, water valves, manhole covers, fire hydrants, what you know of as your standard existing features. Linear features include chains, but it also could be a baseline that's horizontal geometry. Surface features for surveyors would be mostly what we would consider existing ground or bridge decks. Each feature definition will have its own set of properties that can be defined. What you're seeing here is some examples of features that have been selected and show up in the element information box, also known as the properties box. First one is a single support sign, and you can see the attributes that are important for a point feature. In the second one, a baseline has been selected, and you can see there's some additional attributes for linear default settings, profiles, cross sections. And in the third example, the DTM existing has been selected as a feature definition for this surface, and when it shows up in the element information box, you have surface defaults. So the point of all of this is that the features and feature definitions affect the points, the chains, and surfaces, and the attributes that are associated with them. There's three ways to apply feature definition in the FDOT SS3 and SS4 software. You can link to native. Linking to a geopack DDB file is considered linking to native. They can generate attributes and features based on what that DDB file has in it. Survey features also are linked to the geopack SMD, which is, with a few tweaks, becomes the XML. And then element templates are the third way to apply a feature definition. They override the others, and they allow for a variety of attributes for a single feature, such as a terrain model. Feature definitions, once in the file and once the file has been populated, will show up in your Civil Standards tab of the Project Explorer. And here you see some examples of feature definitions from roadway plans, 2D. In this case, there's a baseline in the file. You have survey display features, and you have terrain display features. How they are visualized are integral to the way that these feature definitions are set up. This is an example of an element template. This element template is specifically for terrain models, and this one is for existing ground. It has a set of properties in the element template that can be filled out. In this case, the feature displays for the contours, triangles, the flow lines, low points and high points, and the vertices are all turned off. Specifically, the triangles are turned off by default. In the source features display, you can see the boundary is turned on right here. The element template also has other attributes. it controls the calculated feature settings for contours. In this example, you can see that the slope option has been set to none, but the contour smoothing factor is 5 and the smoothing is set to none. This is also where you set your major and minor intervals. This is an example of a surface that has been selected that has the element template applied that we saw just a moment ago. And as you can see, the triangles are off and the boundary is on. And down at the bottom, where it's DTM existing, the feature definition can be set. It's showing as DTM existing, but it can be changed at any time through the element information box, also known as the properties box. Also wanted to talk a little bit about the importance of the FDOT resource files. These files are specific to FDOT SS3 and SS4, and you should resist the urge to mix them with other versions of our software. The right-of-way display.xml is new in the Casey data and the Geopack database. The survey display also is new in the Geopack database. These come directly from the FDOT SS4 SMDs and the right-of-way SMDs. We needed to name them a little bit different. We didn't want to just name them right-of-way display SS4 because it means nothing to the user when it's in a set of feature definitions along with roadway design or terrain models proposed or existing for that matter. And if it just said FDOT SS4, you really wouldn't know what it means. So by changing the name and having it as right-of-way display and survey display, the user will understand what it's for. I wanted to point out that we still have the SYENG cell right here. However, it's not exactly the same as all the previous SYENG cells. There are some differences in scalings. Also, we have the right-of-way English cell library, which replaces what used to be known as the survey cell library, but for clarity, we changed it RW for right-of-way. This cell library also should be used with SS3 and SS4 and resist the urge of using older cell libraries because this one has, again, scales set specifically for this software. It also has annotation scales set for some of the cells. Here, as you're looking over at the DGN library within the FDOT SS4 software, you see a new set of folders under DGN Libs for specific DGN libraries. In this case, we want to look at the features DGN library, and under that you'll see FDOT Civil Features Right-of-Way DGN library. This comes directly from the right-of-way DDB that I talked about earlier. There are element templates DGN library, where the element template you saw earlier for existing DTM resides. And then you have the survey features for roadway DGN library and the survey features for right-of-way DGN library. This is where the survey display XML and the right-of-way display XML will reside and automatically load when you start the FDOT state kit for SS3 or SS4. One final thing in the resource files I wanted to talk about were the seed files. Support calls come into this office with people who use old seed files, so it's very important to realize that for the FDOT SS3 and SS4 you use the current seed files. There are settings and filters in these seed files that are specific to the SS3 and SS4 software. So resist the urge to use old files. It's one of the most common mistakes we see. And if you're starting a new project and you want to use old data, reference it in, merge the master, copy it in, whatever you have to do, but resist the urge to use an old file for the active file in your project. You also have, when you're in the right-of-way configuration of our workspace, you want to use the right-of-way seed 2D because, again, it has settings in it that not only allow for certain functionality, it keeps other functionality from happening that causes problems. At this point, I want to talk about the characteristics of the SS3 and SS4 DGN file versus the Legacy DGNs that you normally see. I'm going to talk about the element templates and show you where those are. I'll also talk a little bit about the element information box, the Project Explorer, and the Civil Tools task menu. If you look right here, I have a new file open. The Project Explorer is open in this case, but if it's not, it'll probably look something like this. The element information box is also up and docked, but if it's not, there may not be anything up. So I wanted to talk a little bit about what you're going to see and how to get to these. There's multiple ways to get to the Project Explorer. Along with shortcuts, you can also go to File, Project Explorer, and open it. There's also, under the Tools, down at the bottom, you'll see Survey, Processing, and there's a Project Explorer here. It also can be opened from the Task menu. Under the Survey Drawing Settings, you'll see Project Explorer. Once it's open, you can dock it or keep it in the same place. In this case, I'm going to pull it out, just kind of look at it right here. Also want to talk about the element templates. If you look under Element, go down to Element Templates and pull them up. In a blank file like this, what you'll see is the file itself, which is right here. And then you'll also see the element template DGN library that I mentioned earlier attached right here. If you expand it, you're going to see feature definitions that are set by design. In the case of terrain models, the one we looked at earlier, it would be right here. If I choose it, you'll see all those settings that we looked at earlier. Notice that they are grayed out. That's because we are looking at the element template within the DGN library and not the one that's actually attached to the active file. The element, once data has been entered into the active file and the element template used, then and only then will those element templates show up under the active file. The element information box is also another important aspect of the SS3 and SS4 DGN file. It's always been important, but at this point it is being used as a property box that can control various aspects of the software. If you open it, you can open it by hitting the I or using Control I, or just going to Properties under many of the selection sets that you'll see. Right here I have it docked. It can sit out. When something is selected, you'll see it show up in the element information box. In the Project Explorer, we have the old Project Explorer would show the old links and files, but nothing else. So it's been around for a while. The new Project Explorer has a Survey tab, has a Civil Models tab, and it has a Civil Standards tab. Under the Survey tab, you'll see Survey Data, and then as you expand it out, you'll see Field Books, and you'll see Filters. We have preset zone filters. This is coming directly from the 3D seed file, and you won't find it anywhere else. So that's why it's very important to use the current seed file. Under the civil model, you'll see a list of possible civil models. Surveying will build alignments, and they will show up under linear elements. Anytime you build a horizontal geometry element, it's going to show up under linear elements. And alignment is a horizontal geometry element. Terrain models, when you build a terrain, will show up under terrain models. Under the Civil Standards tab, you'll see under the active file a set of categories, one of them being feature definitions. If you expand it, you're not going to see anything at this point. This feature definition category will get populated once data is brought into the file. Specifically, that data, when brought into the file, will use the feature definitions from the FDOT Survey Features Roadway DGN library. Right here. If you expand it, you'll see our feature table, survey display with default points, our DTM existing our existing drainage, topography, utilities, and then various plan view elements. Once data is brought into this file, these feature tables are used, and only the features that are actually in the file will be populated under the feature definitions within the Civil Standards tab of the Project Explorer. Another very important aspect of the Project Explorer Civil Standards tabs is the Project Settings category. If you expand that, you'll see Survey at the bottom. Expanding that continually, you get down to the Survey Settings. You can say Properties, and it will actually populate the element information box, and you'll see attributes that are very important to the survey data that is populating this particular file. What we have here is we have categories under General, Extended, and General Settings where names are set, points, and linking codes. What I wanted to tell you was that under linking codes, they can be set here, and we are headed in that direction as EFB starts to be used less and other software is moving forward. These linking codes will be set for those software. Things like Leica, TDS, those types will use linking codes. We also have a category for data parsing. I wanted to show you this because it is important to show you what can be imported into an SS3 and SS4 DGN file. If I choose this drop down, it's going to open up the Data Import Items dialog box, and we can get a understanding of what Bentley can import. In upcoming webinars, I'll show you how to import a KCPT4 and also XYZ files and control files. Bentley Survey can also process data, so a control file, a CTL can be brought in, and then an OBS can be brought in and read, and data processed using geographic coordinates or geographic projections. Also note a lot of different data files that can be brought in. We're looking at KC SRV and KCP files. As I move down, you'll see various, an XML can be brought in, surface XMLs, and various others that we can use. And also note that you can add a data import item. So if you have something specific, you can add it. You can also use and exclude specific data imports. If you're going to process within Bentley Survey while bringing in a control file and then an OBS, you'll want to set adjustment defaults. They are right here in the same element information box under the survey settings in the Civil Standards tab. So as you can see, this is where your least square adjustment settings can be adjusted. You also have compass rule, transit rule, and Crandall rule that can be used. And at the very bottom, you'll see terrain models. This one's one that you should all know about, because if you ever see an extraneous terrain get created, it's probably because this particular setting is set to true. If you use an old file, it assumes some of the settings that you see here because they're not normally in those files. So what Bentley has done is they have set some specific defaults for files that doesn't have this type of attributes attached. So what they'll do is they'll go ahead and set these settings to their default, and the default is true. I think the maximum triangle length is set to something like 1000, so these settings are really not very good for using in the default state. You'll want to make sure this is false and create the terrain model only when you specifically want to create that terrain model. Also, whether you use no edge method or remove slivers, or as a default we have set maximum triangle length to 100 feet, which is pretty typical of most of the districts. You can adjust that up and down as needed, depending on the density of the shots that the survey crew use in the field. So if the shots are set to 50 feet or 40 feet apart, you may want to reduce this. If in some cases shots end up over 100 feet apart from each other, you may want to increase this to 110 or 120, whatever is necessary. So that pretty much covers the Project Explorer. Note that you can take this Project Explorer, you can dock it, or you can drop it on the taskbar, for instance, and it will actually match the taskbar, the task menu bar, and that way you can switch between tasks and Project Explorer right here at the bottom with some tabs. If you can do the same thing with the element information box, if you'd like to dock it, you can set it over here, just touch that little tab and it'll dock. If you have anything else open that you want, like frequently I will have the level display dialog box open to use level filters. You can just drop it right on top of a currently showing dialog box and it will match up, and then you can switch back and forth, in this case between the level display and the element information with the tabs right here at the bottom. Lastly, I wanted to talk about the task menu bar that Bentley provides. We've seen this for quite a few versions now. Some people like to use it, some don't. But what they now have in SS3 and SS4 is beyond what they've had before. They don't just have drawing, for instance, where you find your drawing tools. They have civil tools. And in the civil tools, you'll see a number of categories that directly relate to 3D modeling and the surveying end of it also. You got analysis and reporting here. You've got general geometry, horizontal geometry, terrain modeling. These are specific for surveying, and then you have the surveying category. If you select the civil tools, it will show up in the task menu bar, and then you can go directly to reports if you want to see a horizontal geometry report, for instance. Under general geometry, you're going to find where you set feature definitions. You're also going to see some tools for importing geometry from GeoPack or other sources, and you can export to native, which is also GeoPack. By hitting this selection, you can export horizontal or general geometry directly to the GPK file. You also have horizontal geometry. This is where we build alignments in surveying. We can put in lines and curves. We can also build these alignments directly from the GPK file. We have reports that we can choose on these lines. If we have an alignment, we can turn it into a complex element so we can station it. We have start stations and station equations, and the functionality of these actually are quite good. It's very easy to put a station equation in a GPK file by using these tools. You also have terrain models. If you're going to bring in a terrain model from another source, like a TIN file, you would use this button right here, create from a file. You also can create from a point cloud. You can add features and remove features right here. This one's important because you can edit to your terrain model from this button. And you can analyze your terrain spot shots, between points. You also have a tool for reporting crossing chains, and you can export those terrain models. Also wanted to talk about the survey task menu bar for a moment. Of course, you got the Project Explorer, but you also have a Show Details. This is where you see actual points and chain information within the DGN database. You can also hide these details. Another one that's very important is the Survey Redraw tool. This one you'll use quite often. Anytime, it also gets done automatically as you make edits, but anytime you bring in data or change annotation scale, you may have to end up doing a survey redraw. Also note that if you do a survey redraw, it revisits the feature definitions and will reset any kind of rotated cell back to its original position. So things like signs and other points and cells that you want rotated to different positions, you want to do that at the very end because survey redraw will reset those. Okay. You can load data directly from here. You can also edit. These are chain editing of linear features. And then you have your reports, and then finally there's a way to turn on and off annotations, specifically point annotations, point names, elevations, descriptions, using this tool right here. So this is your civil task menu, and it is very important to the overall workflow. We also have, under Civil Tools, an FDOT Plans Development task menu. If you open it up, you're also going to see one that was created for survey. It's sparsely populated at this time. We'll add more to it, but it has the survey redraw tool, the show and hide details and reports, also some of the commonly used horizontal geometry and general geometry tools, and then a couple of the tools that you'll use quite often in developing your terrain models, and that's the edit terrain model and reports crossing features. So we also have settings that you need to be aware of when you open up a new file in the FDOT SS3 and SS4 workspace. Geographic projections are important now. And you'll also want to visit your maximum triangle length. On most jobs, you'll need to decide what that's going to be and set it up front. Another setting is in the workspace configurations, and this one's very important too. This is new. You will see in SS3 and SS4 in your FDOT menu when you're changing between roadway and right-of-way configurations or adding configurations to your roadway configuration, you will see that there is an Include Survey Features checkbox. When this box is checked on, survey features will be available. They'll show up in your feature definitions. It's important for the surveyor because they'll need to see it. The reason there's a checkbox there is if the roadway designer is using his feature definitions or his or her feature definitions in the design, they don't want to see the survey feature definitions because they won't use them. We have over 400 feature definitions, and they will get mixed in with the roadway design feature definitions. The roadway designer does not want to see those, and so by checking those off, it helps them to be able to sort through their own feature definitions. There's also another aspect of this checkbox, and that's when the box is checked off. The DTM criteria for tolerance along break lines will be 5 feet, meaning that every 5 feet a triangle will get generated along a break line. This is good for proposed surfaces. This is not good for existing surfaces. Survey usually does not shoot the project to that density. It's way overkill, it's expensive, and it doesn't really add anything to the existing terrain model. So when this box is checked on right here, the linear stroke tolerance for break lines will be set to 50 feet, which is pretty standard throughout the industry for surveying. If I go back to a populated file, I wanted to show you a little bit about what the difference is and what you'll see in a populated file for the element templates, the element information box, and the project explorer. In this case, you have the survey tab open. If you expand it, you'll see the filters as before, but we also have something called a field book. If you delve deeper into the field book, you're going to see the import event for this particular one that has points and features. Here's points. Here's the linear features. Remember, only the linear features that were used in this file show up in this list. All the others are not shown. You also have all point features from all import events. In this case, it'll be the same. You have all linear features for all import events. They can be visualized on and off simply by checking this box on and off. When you select an item in this, for instance, if I select a monument, you'll see it show up in the element information box. These are the point features that I showed you earlier. If you're looking at civil models, once you expand the categories, you'll see that in this case, linear features are populated because we have two specific alignments in this file, AL1. If I select it, you can see that the element information box, I'll pull this over here a little bit, is selected, automatically populated. You can also select the alignment itself, and again it'll show you the same population. In this case it's AL1, and the feature definition is baseline survey. The feature definition also controls the level it's on, baseline survey. If I change that for any reason, so if I go back and say properties over here and show it, if I change that to say centerline, for instance, it will change. Note that the level is changed to centerline construction. Also have another alignment down here at the bottom. If I select it, you can see it's set at centerline construction in this case. If I change it to baseline, note that centerline construction changed to baseline survey. Also, over in the civil models box over here, you'll see any 3D linear elements that happen to be in the file. In this one there's not any, but if you see terrain models in the file, it'll show up right here. If you select it, again, it populates the element information box. And this element information box can control the way it's displayed. If I want to see triangles, I can double click on it or use the drop down for on or off. If I want to see contours, again, I can select that to make contours on and off. And if I want to change the DTM feature definition to something else, I could change it to DTM proposed, for instance, and it would change the feature definition and how it looks and the characteristics of it, because these come directly from element templates. Note you can select the terrain on screen and get the same results. If you look at the Civil Models tab, you'll note earlier there were no feature definitions under this category right here in the active file. They were only down here in the DGN library where it draws from. But if you look at now with a populated file, you'll have feature definitions. We have 2D plan, which happens to be the baseline that we were looking at. We have the survey display features, which are the drainage, topo, and utilities that were collected. And we'll have a terrain display right here. In this case, because I've used both DTM existing and DTM proposed, they now show up under the terrain display. So these are many aspects of the DGN that you will not see in the old Legacy DGN files. This is 3D modeling. These are 3D files. They are not 2D. They are 3D. It is important that you understand that for building terrains, you can't just bring in old CDG files or microstation elements that have no attributes attached. You will need to bring in and use the terrain model for the SS3, SS4 workflow. The last thing I wanted to talk about was avoiding some of the pitfalls that we have seen coming through this office when consultants call in for support. So when you start a project, you want to always use the latest FDOT SS3 and SS4 seed files to avoid issues with the survey settings, for instance, the maximum triangle length, the auto terrain generation. Also, we've seen problems where an old seed file was used and it introduced unwanted resource elements like custom line styles. So just avoid using old seed files and old projects. Reference them in, bring in the data, but don't use those old DGN files because it's hard to predict exactly what will happen. Also, you want to make sure you use the 3D seed file for the design survey. The 2D will not model and you won't have survey filters. And another pitfall you want to make sure you understand is when you bring the 3D survey data out and you want to go into a right-of-way configuration, you want to open and use a 2D seed file for right-of-way, because right-of-way uses masks for text and for monuments, along with other elements that cause problems in the 3D environment. The 3D just really does not know what to do with a mask, so you might end up blanking out large areas of your file. So just be aware to use a 2D seed for your right-of-way work, use a 3D seed for your design survey work, and you're golden. So that concludes my presentation. If you have any questions, you can contact me at the email address below, and we'll also entertain questions from the audience and attendees. Thank you very much. That's the end of my presentation.